Hello, everybody. Welcome back. We shall continue our journey into the world of Scratch with a very interesting activity today. Today, we will build the familiar and popular catch game. So, we shall be building a version of the catch game uh, which will help us to reinforce one, how to make games, of course, and two, how we can use variables to make our games more and more interesting and add features to our games. So before getting forward, let's see what we are building today, right? So today we have this a simple catch game. Now the game is very simple. We have a bowl at the bottom here, and there are fruits falling from the sky. We have to catch apple and oranges, right? So apple gives us 10 points, as you can see here. Oranges gives us 15 points, but if we catch a watermelon, we lose 25 points, right? So, we have to score as much as we can. And additionally, we have 30 seconds to score to play in this game. So we have a time left, we have a score, right? So let's see how this looks like, right? So, oops, I caught a watermelon by mistake. Okay, so I'm doing okay, I guess. I move this ball by moving my mouse. So you notice that watermelon actually falls a bit faster, which makes it a little bit harder to avoid it sometimes, right? Compared to catching orange and so on and so forth, right? And now, when the time is over, it just tells us, okay, look, your score is whatever it is, and it says time is up. Well played, right? So this is the game we are going to build today. Let's see how we can do this in a systematic, step-by-step manner, right? And like I said, in this process, we will understand how variables are used, uh, how the whole thing comes together, right? So let's get started, right? So uh, basically, we will start like blank slate. So we have got nothing in here. So I'm going to first remove my cat sprite because I do not need this for this game. And what I'll do is to add two sprites, right? So I add two sprites and a background, right? So remember the backdrop we used in our game was this backdrop called the hay field. I liked it very much because it just gives this feeling that we are in a field and things are falling from the sky, right? But of course, there is no um, compulsion that you must use this backdrop. However, for this video, this project today, we will use this backdrop called the hay field, right? And it looks something like this, right? Now, having done so, I'm going to add exactly two sprites, right? So now you remember in my game, in fact, I had four sprites. One is the bowl and these three fruits, right? But what I will be doing now is to add exactly two sprites. And the reason for that will become obvious as we go along. And in fact, that's a good practice because it lets you build things in a step by step manner, right? So what I'll do is I'll go here, choose a sprite, and I'll say, look, I want a bowl sprite, right? So I add this bowl, right? And then I'll also add, in my case, an apple sprite, right? Because remember, it was apple, watermelon, and orange that were falling from the sky. So I shall, add these two. The bowl I can make maybe a little bit bigger, probably. So it's 100 right now. I'll make it say 120, right? Just for the, for the game. And the banana, I guess I can make it little bit smaller, right? It's rather big for the bolt right now, so I'll make it 50, right? Now, again, this is not necessary, it just depends on what you're trying to build, right? But the important point is that though eventually we will have three kinds of fruits and one catching ball, right now I have added only one fruit, right? Because I want to get my code okay for this before adding the new sprites. And in the process, I will also teach you a very smart trick that lets you develop code much faster, right? All right, so let's move forward, right? So remember, the ball, as far as the ball is concerned, in our game, the ball has to be somewhere on this side, on the bottom of the arena, right? So we, that's quite easy to do. So let's put a little bit of code for the ball. I say events when flag clicked, right? So I always start my game with the flag getting clicked. I say go to motion block, say go to, where is go? Yeah, go to, let's say I say I'm going to focus more on the y value here. I'm saying going to say, let's say I say go to some x and some y, right? Now, the x here is not important really, because all we want is that the ball should come somewhere at this part, right? And this part really anywhere here is okay, so long as it's coming down from here, right? And recall 0 0 is right here in the center. So if we come down 150 steps, we are going to end up somewhere here, right? Now, some of you might want to do maybe 145 or 148. That's okay. But approximately, if I did this, my ball will come. So when I click the flag, it will come here, right? So it's okay if it came here, or say it came here, it came here. It doesn't really matter. So X value is really not so important at this point of time. But remember, in my game, I was controlling the ball. I can show you again. I was controlling the ball by moving my mouse, right? So what I want to do is that I am sending, by using a go to statement, I am sending the ball to the sort of the bottom of this stage. Thereafter, I want the mouse to control its X position, right? So why X position? Because I want the mouse to control how the ball is moving along the sleeping line, along the horizontal, right? And how do I do that? It's actually quite straightforward, provided we use basics. So there is a block in motion block called set X to some value, right? Now, in this case, I'm going to say set X to, go to sensing, and I'm going to say set X to mouse X, right? Now, what does this mean? Sensing mouse X. What does this mean, right? So mouse X is basically the X coordinate of the mouse pointer, right? So if I basically put, let's say, remember this is 0 0. So anywhere along this vertical line here, mouse X is also 0, right? Because it's telling you the X position of the mouse pointer here, right? So as I move my mouse pointer, let's say, here, its X value is changing. And what we are saying is, for the ball, set the X value to whatever X the mouse has, right? So which means that if I move my mouse horizontally, it will change its X position, right? Now, some of you might wonder, why don't I use go to mouse pointer, right? That's a reasonable approach. However, what happens in reality is that, let's say I can show you here. Sometimes when we're playing, our mouse is perhaps maybe in the sky somewhere, right? But we are able to control this, right? So if we added go to mouse pointer, the ball will keep on moving towards the mouse, and it will be quite disruptive, right? So all we are saying is that the X position of the ball, which is its X, should be equal to the X position of the mouse, right? And remember, we want this to happen for ever and ever again in this game, right? So we will put this whole thing in a forever loop, right? So now the code becomes something like this, right? So when flag clicked, go to, say in this case, x of minus 12, y of minus 150. The important bit here is minus 150, because we want the ball to come somewhere to the bottom of the stage, right? So that's the minus 150 part. Thereafter, forever, set x. Now, this x refers to the bowl x to the mouse x. And let's see what happens here, right? Simple, very simple, right? It's just moving. So as I'm moving the mouse, it's moving here, right? Now, even if I move my mouse here, it doesn't matter, because all I'm looking at is the X position of the mouse, right? Which is telling basically from this somewhat approximately the center line, vertical line here, how far I am, right? So if I'm to the left of the line, which means my X is negative, right? The ball's X position gets set to that value. If I go right, it gets set to that, right? So it's just basically a simple way of saying that my ball is going to move along with the mouse, right? And that's that's really all we need to make our ball move, right? So I'll stop this here. Now, let's say, you might wonder that why don't I use arrows for this process, right? Yeah, certainly you could. Just like in the maze game, for instance, right? Some students like to use arrows. So in which case, what you have to do is, forever, if arrow key pressed, say for example in sensing block, you can say forever if, let's say, key maybe right arrow pressed, then move, change x by 10, or say set x to x plus 10, or move 10 steps in the right direction. There are many ways of doing it, right? But I just find it more intuitive to use the mouse. So I'm using this method, right? But certainly you're most welcome to try in your own version of the game to use the arrow buttons if you so feel, right? Now let's go to the apple. Right now, what does the apple do? Right now, like I said, there are multiple sprites in the game. However, let us just for the moment focus on the apple. Right, so what does apple do? So apple, if you look at the apple, it's always falling from the sky, right? So it goes up to the sky and it falls, right? So that's all really the apple is doing, right? So there's like, if it, let's say, goes all the way here, then it comes back again and it falls, right? So all we have to do is to use some kind of a motion block to make sure that apple goes to the top here somewhere, falls down, then goes back to the top and again falls down, right? Really, that's all the apple is doing as far as the motion is concerned, right? We will get later on to figure out how does apple know that it has been caught, or how does the ball know that it has caught the apple. That's later, but as far as the motion is concerned, we are going to just use apple to fall down. We are just going to make the apple fall down, right? And how do I do that, right? Let's do it in a few steps, right? let's say let's say I say, look, when flag is clicked, right? So now I have to go to the apple code. I say events, when flag is clicked, right? I tell apple to go to, right? Let's say I go here in the motion, I say go to, uh, remember again. So let's say I fix this x, go to 64, and I want to send apple quite high up in the sky, right? So perhaps I can set the highest value, which is say 160, y of 160, right? So what will this do, right? When I do this, apple is kind of stuck there, right? Apple has gone to the top but is stuck there, right? Now if I wanted to fall down, what can I do, right? Again, there are many ways of doing so, but what I will do is to add a code which, in simple words, changes the y value of x. Remember, y is climbing up or down. So if apple is already standing on level 160, if I can make its y value reduce, right? Which means, say, from 160, I make it 150, then 140, 130, and so on. It will look like apple is kind of coming down, right? So let's see how we can do that. So I can say, look, apple, go to this point, right? Thereafter, go here, uh, say, change y by, change y by, let's say I say minus 10, right? Now we have looked at set and change in context of variables, in context of the pen block. This is exactly the same, right? So remember, change changes the present position, present value by the value we are saying, right? Set is basically setting to a fixed value. Change means it will change from whatever it is right now by the number we are giving, right? So we are telling y, telling the apple, change y by minus 10, right? So what this means is, apple, please reduce your y by minus 10, right? Which means, please reduce your y, sorry, by 10. So which means, if it's 160 right now, when I click the flag, and we can in fact see it here, apple's y is 160. When I click the flag, it becomes 150. If I stop and click the flag again, right, it again becomes 150, because remember, it went back to 160, changed by minus 10, right? Now let's say, now let's say I put this inside a forever, right? So what happens then, right? So if I go here and I say forever, change y by minus 10, right? So what will this do? This will basically make the apple change 10, again change 10, again change 10, again change 10, and so on. And hence it will look like the apple is falling, right? So if I, every time I click the flag, apple is falling, right? So now all I really need to do is that, remember, what is my apple's code in the actual game, right? Apple goes to the top, right, and it falls down. After coming back here, it looks like suddenly it's falling down again, right? And how can I make that happen? All I have to do is I can say, look, apple, what you should do is, after you're reaching this position, right? Once you reach this position, please go back up again. And then anyway, you are forever changing y, right? So how can I do that? I am going to use the if condition for this. And I say if, right? If now I go to Apple, right? Remember, we are writing the code for Apple. So I say if y position of Apple, which means how high Apple is. Okay, so I can't put a circle directly there. So I have to use an operator. And I say if y position, now remember this refers to how high the apple is. I say if y position is less than, let's say, minus 159, right? Now, why did I say minus 159, right? Because remember, it's like saying apple is falling down, it's climbing down 10 stories each time. After it has reached story number 159, below, I mean, it's gone to 0, then minus 10, minus 20, and so on and so forth. At some point, it's going to reach minus 160, right? So, which is basically less than minus 159, basically lower than 159, right? If that happens, then I want Apple to just go back up to the top, right? So I can take this statement, I can duplicate this portion, just this portion, I don't need all of this, and I can send Apple back here. So let's see what this does, and then we can go slowly as to what's going on here, right? So Apple comes here and then Apple goes back there. Why is that happening? We can, like I told you before, a very useful tool to debug all of this is put a small weight, right? And then you'll see what's going on here, right? Let's say I put weight of zero point 0.1. You'll see Apple seems to be falling in sort of like, small increments. It reaches this point, it goes to, if you look at Apple's y position, it goes low, 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 goes to minus 160. And then because of this condition, because we have this condition that if Apple's y position becomes less than minus 159, right? Now this negative numbers less than could be a bit confusing, but think of it this way, right? That you are going into a building in the basement, right? So now you are climbing down, climbing down, climbing down, right? Every time you climb down, you go down one story. You reached floor number 160, which is one floor below 159. The moment that happens, you are shot up to the sky again to 160, right? The y of 160, right? So that's all that Apple is doing, right? Now see it again. So Apple is coming down, its y is decreasing, decreasing, decreasing. It reaches 160 briefly, if you noticed, and then it goes back again there, right? So we can, in fact, if you really want to see this more carefully, you can put a weight here. Maybe let's say I put, let's say, I put a weight here. And then what happens is that, it'll fall down, but it'll stop here at 160 and then it'll go back, right? 160 and then go back. So with this, right, I don't need the weight here. You notice that I can, weight was just for us to see. But with this done, I have a code ready where Apple is coming down, and the moment it reaches the ground, it again goes up, right? So everything looks nice. Now, the problem right now is that Apple is always falling from the same spot, right? So it's very easy for me to catch my Apple because all I can do is to put my ball here, right? And it will keep on catching Apple. So what can I do to avoid this, right? Now, thankfully, Scratch gives us a very nice method of handling this, right? And in fact, the concept used here is applicable in all programming languages, right? So remember, what do we really have to do, right? Our x right now is fixed at 64, which means Apple is always falling from here. If we had a way, if, right, we had some way of making Apple go anywhere between here and here, right? Anywhere. We do not know fixed here, here, or here. Every time I go back to a point, it could be here, it could be here, it could be here, right? The way to do this is to use a random number. Now, what does random mean? Random means that it's not a fixed number, it's a number in a certain range, right? So in operators, the green color button, there is a block called pick random. I'm going to use that. So instead of x fixed here, I'm going to say pick random between minus 240 and 240. And why I do not need to change. So what this will do is that every time my flag is clicked, x will go to a random position, right? But remember, it's again going back to 64. So to avoid that, I want it to go back also to a random position, right? Which means anywhere here, right? So I'll just copy this, pick random minus 240 to 240, and I will place it here, right? Now, what will this do, right? It will, let's see, it's easiest if we see this ourselves, right? Basically, we have, it's, you see that Apple is coming from different positions. It's like falling from a different position every time the code. So every time it falls down minus 160, it goes to a different position, right? And why is it going to a different position? This time it went to extreme left, right? Because we are telling it, pick a random number, pick any number between minus 240 and plus 240. Whatever it shows up, please go to that value of x, right? Remember, this is just to set it once in the beginning. After that is this loop that's going on. So in this loop, whatever value of x the random number picks up, you please go there, right? Now you might wonder, why did I use minus 240 to 240, right? Remember, this is from the if you look at the XY grid, the minimum X value is minus 240, which means Apple can take 240 steps this way, or Apple can also take 240 steps from the center to the right side, right? So these are the limits in which we want the Apple to go, right? And hence it just makes sense to put this, pick a random number between minus 240 and 240, right? And with this, you see that Apple is basically falling nicely to different positions, right? Now, one thing here is that, you might wonder, I mentioned about variables, but we haven't used any variable, right? So how can I make this code bit more flexible, right? And what do I mean by flexible, right? Let's say I want to change how fast my apple falls, right? So what is controlling that really? You think about it. If I change y instead of 10, if I change my minus, say minus 15, right? You will notice that apple will fall a lot faster. It's probably not so discernible, but let's say I made it minus 1, right? It's simple because every time y will be changing position by only 1, right? The apple will be changing position by only once, like taking a slow elevator, so it's coming down slowly, right? So it will be nice for me to have a control on this, right? Have Apple remember how it is falling, right? So what I will do is I will go to the bowl code and I will create a variable called, I'll make a variable and I'll make it available to all sprites, right? And I'm just doing so because it's just convenient. I'll call it Apple steps. Let's say I call it Apple, you don't need underscore actually. I call it, say, Apple steps, right? For all sprites. And when I create this, I can say, I can set a block here when flag clicked, right? Variables, set Apple steps to maybe minus 10, right? So if I do this, then remember set means to fix its value. So Apple step will get fixed to minus 10. I can now go to Apple and say, instead of change by whatever minus 1 or something, I can say change y by Apple steps. So what this does, right, is that if I, let's say, want to change my code, it's displaying Apple steps there. I don't really need to, so I can hide this. That was a normal readout, right? Now, if I want to, let's say, make my game faster, then all I have to do is to change this to minus 20, right? And you will see the benefit of this once we have, you see the Apple is falling that much faster, right? Once we have many sprites and so on added forward to this, right? So now, so far, what have we got, right? So we have got a bowl, we have got an apple that is falling from the sky, right? So now let's add a little bit more code for apple, right? So what we can say, I can tell the bowl that, look, if I catch apple, right? If I catch apple, please change the score by some number, right? So remember, in my game, I wanted to give Apple 10 points, right? So I will write a little bit of code for the bowl, right? Now you could also do it in Apple, but it's just convenient in this case to put it in bowl, and it will become somewhat clear, right? As we go about this. Now, so what I'll do is that I will say events when flag click. Now I'm doing this for the bowl. I say, uh, you know, in the control block again, I say if, right? And what I can say is if touching, right? If touching, say apple. Remember, when I take this drop down, I basically get all the other sprites that are available, right? So it's a if touching apple, then I say change score by apple points, right? So now what does that mean, right? So I say I want to increase the score, right? So which means that I can use now, I have to basically remember through this game what is my score, right? So somebody in this whole thing has to remember what is the score, right? Now, another way to look at this is that bowl is like a container, right? So this container has to keep track of what all it has got, how much, weight or something it has got, right? So we can create a variable here called, make a variable called score, right? So I create a variable called score. Again, I make it available to all, all sprites. And in the beginning, it makes sense when flag is clicked, it makes sense for me to say, look, score should start from zero, right? It doesn't, it's odd if the score starts from some number. So I'll reverse these two. Now I'm saying is that if, ball touches the apple, probably I should get maybe say 5 points or 10 points, right? Now I might want to change this in future. So I use a variable called apple points, right? And what I mean by that is how many points do I earn if I touch the apple, right? So if the ball catches the apple, so I can say set apple points to maybe to 10, right? Uh, Again, all of this will make sense to you. I think apple steps 20 is too fast, so we'll make it -5, right? Apple points is 10. So what we will say now is if you're touching the apple, right? Change. Remember, we have set the score. Now I'm saying change score by apple points, right? So what this will do is that it will open the box called score. It will add whatever is on the apple points, right? So apple points is 10, so it will increase score by 10, right? Now in this touching blocks, because the apple is always falling, I want to make sure that I register only one touch, right? One touch event, right? So it's very simple. There are actually other ways of also doing this, but a simple method which I think is okay is to add a small weight here, right? So basically what this will do is I'll add say 0.4 seconds. It will not change your game dramatically, but what this will do is that it will make sure that if the apple touches the ball, the score does not keep on increasing. Instead, it increases a little bit, waits for a while before it checks for touching again. Apple would have disappeared, hopefully, right? And we'll have to fine tune this a little bit. All right. So now we are saying when flag clicked, if touching apple, change score by apple points, right? Let's see how this code works, right? So when I click the flag, right, you notice that nothing is happening, right? Now, why is that? Because we have forgotten a very important friend called forever, right? Remember, in this code right now, in this code right now, the condition that if touching apple is checked only when the flag is clicked, not thereafter, right? So we want to be checking that condition all the time, right? So all we have to do is to put a forever block, right? I intentionally do it this way so that people remember that forever is important, right? Now when I do this, you see what happens, right? So apple comes here. You see now the score is incrementing 10, 20. So every time I catch apple, my score increases, right? So much so for the apple, right? Now let's say I want to add, a little bit of sound perhaps for the apple to be, when the apple falls into the bowl, let's say I want to add a little bit of sound. Now remember, this is an event sound, so I'm going to use, say I'll use pop, right? So pop is a nice sound, so I'll say use pop, and I'll use start sound for this, right? So I'll say start sound pop, right? So say change score by, I can do it here, right? So now what happens is whenever apple falls here, I get a small pop, right? So I know that apple has been caught. Yeah. So this is very simple, nice, right? Apple is being caught, and you see the score is increasing by 40, 50. So Paul is kind of remembering how many it is caught through the score, right? Now, so far we have got a very, very simple version of the catch game, right? Now, please hold your breath because in the next few minutes, this game is going to expand to become whatever I showed you earlier, right? And now, which this is where you'll see the power of variables. This is where you'll learn a method of how you can do code really fast in Scratch, right? So now remember, I have orange sprite and watermelon sprite along with an apple, right? So one method could have been, let's say I want to add orange, right? So I go and say choose a sprite and I say orange sprite, right? So let's say I go and say, where is my orange? I can search here, say orange sprite, right? So I can choose orange sprite and then I can write all the code again for orange, right? I recommend you do not do this, right? So I'll delete the orange sprite. Instead, what I'll do is I will say, I will right click on the apple sprite and say duplicate. All right. So see this again. I'll right click on the Apple sprite and I'll say duplicate. All right. Now, what that does is that not only does it duplicate the Apple, call it Apple 2, but it also copies over all the code that you had for Apple into Orange. Right now, why did I do this? Because fundamentally, in my game, Apple and Orange are doing the exact same thing, right? So I can just say, okay, look, put it all in the, same code. However, now Apple, I want Apple to be called as Orange. So I'll call this Orange. I'll just rename it to Orange, just Apple 2. And I will go and change its costume to an orange costume, right? So what I'll do is I'll remember, choose a costume. And once I say choose a costume, then all the costumes that are available to Sprite are available to oh sorry, I made a spelling mistake. So I shall use this orange and I can delete this costume. So suddenly from having just one sprite, we have two sprites. And the best part really is that this sprite is already working. Why? Because all the code that was there for Apple has been brought into Orange as well, right? But remember, we want Orange to be different in the sense that, just like we have this, so I can duplicate this code. I can tell my bowl that if touching, in this case, orange, right? Maybe I do not want to say play a sound pop. I can add some sound here. I can add a sound, let's say coin or something, right? Let's say you can choose any sound, right? As I say, I go into this code and say play sound coin, right? And remember here the score changed by Apple points. I can define a variable called orange points, right? So what do? I say go variables, make a variable orange points, right? And orange points is the points that the sprite scores by catching an orange. So maybe I can say orange points could be, let's say, maybe 15 or whatever you want. If you like oranges more, you can give more points to oranges, right? And here, instead of Apple, I can say change my, change score by orange points, right? Now, one more thing is that if I did this, right, then you notice that orange and Apple are always falling at the same speed. Why is that happening? Because remember, we duplicated Apple's code into Orange code, right? So which means Orange's Y is also changing with Apple steps, right? Now we may want to make Orange faster or slower, right? So one method would have been to go and change here. However, an equally good method, in fact, a better method is to use a variable called, let's say, orange steps, right? So if I did orange steps, then I can say, look, in the beginning, set orange steps to, right? Set orange steps to maybe, let's say, minus 10, right? So now orange will fall twice as fast, provided I go into orange code and I, change this to orange steps, right? So now really I've done things little bit fast intentionally, because what you notice is that suddenly, right, almost suddenly, from having one apple, one bowl, I have got two fruits falling with different speeds, with different score, right? So my game has become that much more lively, right? So you notice orange making a different sound, and orange points are increasing by 15 every time I catch an orange. So orange is more valuable to me, right? Now somebody might say, look, I like my apple to fall faster. No problem. All you have to do is to go and change this apple and orange steps, right? So you notice that by doing this duplicate and adjusting variables, how fast were we able to change this code, right? Now let's say we want to do this thing once again, because remember my game also had an had so this orange is looking a little bit small. I'll make it a 70 so it looks comparable to apple. Now remember, I also had watermelon in my game, right? So I also had watermelon in my game. How can I get a watermelon sprite, right? Once again, the method, one method that comes to mind is, well, go choose a sprite, choose watermelon, right? And write all the code again, right? But I will not do that. I will not do that because that will force me to write all the code once again. I might make mistakes, right? I know that my game is working very well with apple and orange. All I'm going to do is to use the same duplicate technique, and I really want you to learn this, right? Because this speeds things up, this makes the project development much more efficient, much more systematic, right? So this time I will right click orange, I will duplicate this. The moment I duplicate, I get an orange 2. I will rename this to watermelon, right? So now the good thing is this, it's called watermelon, but all the code is coming here. Then I go to costumes and I say, look, let's add a costume first called, you know, watermelon, so that it looks like watermelon, right? It looks like watermelon, right? So I say watermelon and I go and delete the orange costume, because in this game I do not have any intention to change costumes and so on and so forth, right? Of course you could, right? But right now I'm not doing so. Uh, I will make this watermelon a little bit smaller. Maybe I'll make it, let's say 50, right? And now I've got a watermelon which is ready to fall down, right? Now the only catch right now is my board does not have code to do understand what to do if watermelon is falling. I can do that by just copying, duplicating this block, right? It's like any of these, right? So I'll take this one and I'll duplicate it, right? Now all I have to do is to say if touching watermelon, right? I drop down, watermelon is available. Perhaps I can add a new sound here, right? So I go here, I add another sound, maybe let's say, call it, let's say, percussion. Perhaps I can take, maybe we'll just take this, right? Let's say, I mean, it doesn't matter really. It's a little long sound. So once again, we'll try if this works. So I'll say start sound, let's say ba, right? Now, if I did this, what will happen, right? Everything will be fine. But remember, notice orange and watermelon are falling. This, I think watermelon sound is a bit too long. That's it. Right? So it's not happy. You could have chosen other sound, but now notice importantly, watermelon and apple are falling together. So watermelon and orange are falling together, and that is because we copied watermelon code from the orange code, and hence it's changing by orange steps, right? How do I fix that? Again, use variables, right? So use variables, create a variable called, let's say, make a variable called watermelon steps, right? So, and I don't need to show it here. I can in the beginning set apple steps, watermelon steps. Be careful here, drop down, choose watermelon steps to, let's say, I want watermelon to fall even faster, say at -15. And I want to deduct points when I touch a watermelon, right? So I will say change watermelon points by, change watermelon. Where is it? Oh, sorry. I have to create a variable, make a variable called watermelon, watermelon points. So I'm going to set this variable, right? So I'm going to set the watermelon points. Remember, watermelon points are the points you will score by catching a watermelon. So I'll say set. Sorry, this is my mistake. I should not be using change here. I should be using set here. Set watermelon points to, but perhaps, -10 or -20, let's say, right? So which means if I catch a watermelon by mistake, first of all, I'm not happy I'm singing this ba sound, and I change the score not by orange points but by watermelon points, right? Now I urge you to do this a little slowly yourself so that you get a hang of it, right? But it's not hard, it's systematic. It's just, so what's happening now? Now if I'm catching a watermelon, right? On the other hand, if I catch an orange, notice I'm almost getting there, right? So suddenly from just having one sprite, I have three sprites, but I just realized that my watermelon is still falling at orange steps, right? So I'll replace this part by watermelon steps, right? And then what happens is watermelon starts falling differently. It actually starts falling a lot faster, and I should try and avoid it, right? So if I right, you could have used some other sound, that's all right, right? That's not the point, but use start sound whenever you're using inside an event, right? That's a lot better, right? Now we are almost there. We were, in a matter of few minutes, we have gone from one sprite to three sprites. The last thing that we have to add is a kind of timer, right? So I'm going to use a very simple concept again to basically give the whole game a timer, and I call it a time left concept, right? So I will start from a certain time. So once again, I want to show the score here. I'm going to create a variable called time left, right? So when I say time left, it's basically how much more time is available to me. So in the beginning, I say set time left to perhaps say 30, right? Because if I want to play the game for say 30 seconds, then I say time left is 30. Now I put a repeat loop. Basically, what I do is that I'll say, I'll create a separate loop for the timer, right? I try to do this because it keeps things cleaner. So I say events when flag clicked, right? Repeat, repeat for, so repeat uh, variables here, time left. So repeat, for example, 30 times. What do I have to do? I really have to just to wait 1 second. So if I wait 30 times 1 second, it becomes 30 seconds, right? And additionally, for my time to be displayed there, I go to variables. I'll say show time left, and I can probably put it here, right? And I can say wait 1 second, and then I say change time left by change time left by say -1, right? So it will basically keep on reducing the time left. So what will happen is you notice the time left button, right? So notice the time left button, it is falling, coming down one by one, right? So we have got this thing added up. Very simple. How this code works is repeat for 30 times. When time becomes, so at the end of these 30 repeats, because it's changing by one every time, at the end of this loop time would be 0, and you will be ready to stop the game, right? And what happens when the game stops, I can give it a new backdrop. So I go to backdrops, I'll delete this backdrop, it's not needed. I can say duplicate this backdrop, right? And probably I can write here, I convert to vector, and I'll write a little bit of text, say, well played, right? Uh, Maybe hope you had fun, let's say, hope you had fun. Um, the the game is over now. Yeah, maybe I can say something, whatever you like, right? And I can, change it to say I can change its, like, in the, basically I can, so I can write whatever I feel like, and I can change its font. For example, maybe it makes it a little bit more, and I can change the color as well. It looks a bit brighter, right? So what I have to do next is that I will say, look, now once the game is over, right? Once the game is over, and how do I know when the game is over? Because in the bowl code, I just have to wait for this whole thing. I can say looks and say switch backdrop to Hayfield 2, and then I don't want the apple, banana, and all of those things to fall from the heaven once this is over. So I can just put control, stop everything, right? Now, in fact, a lot of students do that, and it's good that you can even hide. So you can put, for example, I can go here and say, look, when events, when backdrop switches to, for example, Hayfield 2, you can say looks, right? And you should do hide. However, if you're doing so, then remember to put a show when flag click, right? So I should do it for all the three. I say look, events when backdrop switches to Hayfield 2, then I'll say hide, right? And apart from that, I'll say show, right? So it will just basically uh, hide this whole thing, right? So I say events when backdrop switches to Hayfield 2, I'll say looks, I can go and say hide, right? And remember, here I say show, right? So let's see what happens here, right? So I can just, for now, to play my game faster, I can reduce the time to maybe 10 seconds, right? So let's see if this thing works, right? So, oh, okay. So I have made a mistake here. I should also, so what I should also do is that in the beginning, when the flag is clicked, right, I can put, switch backdrop to Hayfield, right? So I should say when I do this, when the game, so catching a lot of, see, all of them hit, and now my game is over because time left is 10, right? Now, the good thing with this method is that you can change the game any way you want to, right? Now, because we have used variables, These are containers Sprite is using to remember things. It means that if somebody says, look, apple is my favorite, watermelon is also my favorite, but I do not like orange, so I want negative marks for orange. No problem, just change the watermelon points to positive, orange points to negative, and everything will just fall in place for you, right? So with this, I hope this video was clear enough. I hope you got an idea of how to build a catch game. This is a very simple one. There are many extensions you could do. uh, However, for the beginners, it's good to start with something simple, right? Thank you very much. Take care. Bye bye.